Welcome to Natural Habitat Adventures, Daily Dose of Nature. I'm your host, Sunny Vanderstar. Today's topic is El Niño and ecology, what to expect this year. And it will be presented by our fabulous NatHab expedition leader, Eleanor Edye. Eleanor, thank you so much for being here today and for bringing us such a important, there's many words for this, but a really necessary topic. So thank you. Let's dive right in.
Thanks, Sunny, and hi to everybody who's joining us today and who may be watching in the future. As Sunny said, my name's Eleanor, and I'm one of the expedition leaders here with Natural Habitat Adventures. I am personally based out of Canada, so I do a lot of the guiding in our Canadian trips. And in terms of what I'm bringing to the table today, I would consider myself primarily a botanist, but I actually did my qualifications in biogeography and do hold a degree in physical geography. I didn't specialize in climate science, but I do find it quite endlessly fascinating, especially when it has big impacts on our daily lives. So the precursor and what led me to pick this as a topic is that there's been recent news that we're looking at a predicted switch from an El Niño to an El Niño state of being. And I wanted to both remind myself of what that means for my life and my larger world, and look at some of the global consequences that are likely to happen with this too. So what we're going to do today is start by explaining the phenomenon of what El Niño is, what's actually happening in the atmosphere and the oceans on that global scale. And then what I wanted to do as well is kind of zoom in and take a look at a few of the species, of the many species that are likely to be affected by this switch in our climate system. Everything from our blue-footed boobies up to polar bears. These are just a few species we're going to be talking about, but as we'll kind of go through, you'll see that it really is a global change that we're looking at and talking about here. So I'll ask you to kind of put on your climate goggles and think about what we're talking about, and get into the physical part of what things are happening here. To start off with, as a real basic introduction, the name itself, we usually just call it El Niño or La Niña, but what's generally used in the scientific community is, it's called the ENSO, the El Niño Southern Oscillation. So what that kind of tells us is it's a double-barreled name. El Niño is usually what we just call it when we're talking to people, but that proper name tells us that it's actually got a few distinct pieces to it. So it's called the Southern Oscillation because it is a phenomenon that occurs mainly in the Southern Hemisphere, even though its effects are widespread and can affect global climate systems. And it's called an oscillation because there are two phases to this system. And those phases mainly have to do with ocean temperature, specifically in the Pacific Ocean, which then leads to other periodic changes that happen in moisture, wind, and land temperatures as well. So we're not looking at one's normal, one's abnormal. They're just two different alternate normal phases. And we go back and forth between one or the other. The basis for how this all works is a circulation system called Walker circulation, which we're going to talk about right now and what that is and what it does. And it's sometimes called the Walker cell. There we go. So we're going to start by looking at normal conditions that kind of define that Pacific Ocean air circulation system. So this is it's a conceptual model, meaning that you can imagine it, we can model it, and that while it may not 100% express what's happening in real life because we can only have so many things happening in a model, it does pretty well describe what happens in normal airflow circulation in the tropics and in the part of the lower atmosphere called the troposphere. So in the normal Walker circulation, we have, we're looking specifically here at the Pacific Ocean and its areas. And in that equatorial Pacific zone, water is constantly heating up because of solar radiation. That area is always pointed towards the sun during daylight hours. It gets a large amount of incoming solar heat, and that water will start to heat up. So here's a little parcel of hot water here, as demonstrated by our red circle or oval. So here we've warmed up a theoretical mass of water along the equatorial Pacific. And as it's getting that warm sun and it's heating up, it's also going to be blown around by wind. Wind in the tropical Pacific is usually from the east, known as the tropical easterlies or the trade winds. And this is almost always in the same direction just because of how the Earth is turning and the way the pressure systems work on Earth. So these winds are pretty reliably found in the tropical Pacific. Now, this wind is going to move our warm air mass also from the east towards the western Pacific area. So let's move that pocket of warm water. So you can see now it's moved towards the west, butting up against the areas around Australia and Indonesia. So that warm water ends up moving towards the west. It brings with it all that stored heat, and it's going to warm up the air in that area as well. Now, warm air has some very defined physical characteristics. There's a number of things that warm air does better than cold air. It can carry more water in it. So warm air will contain more, or has the capacity to contain more water vapor. Warmer air is also less dense than cold air and tends to rise up in the air column. And as it does that, it carries that water vapor with it and the energy that that water vapor contains. So our warm batch of water has created this warm mass of air, which is then going to rise up in the air column over that western Pacific area, carrying its moisture with us. As that air pocket rises up, it's going to get cooler and cooler as it rises. As it's cooling down, it can't carry as much water vapor, and that water vapor is going to condense and fall to the ground as rain. This rain can be in many forms, right? It could be snow, depending where you are. If we're talking in different areas, it could be hail, it could be thunderstorms, it could be a gentle rain, it could be a monsoon. But rain is going to fall in this area. That air is then going to continue in its circulation cell, moving over back towards the east at a higher altitude as cool, dry air. And then as it reaches a high pressure zone over the eastern Pacific, it is going to come down over the western side of the Americas. And as it's coming down, it warms up, but because it doesn't carry a lot of moisture with it, it's not going to be able to release that moisture as rain, which is why in a typical system, a lot of our western areas in the Americas are drier than other areas. Okay. Now, something I want you to notice before I click over towards the next slide is that we're focusing in on the Pacific here, and we're focusing on the movement of air within the Pacific. But there's two things about this. One is that air doesn't move in a closed cell. It's always impacting areas around it. And you can see that the way that air moves over the Pacific is also then kind of affecting how the air moves in other areas around the world as well by looking at those adjacent cells. And we also talked about how this is driven by the movement of warm water. So water is also moving within the Pacific. So let's take a look at what's happening in the water here. If I can get my mouse, there we go. So next slide up is going to be looking at what's happening within the Pacific Ocean as far as the ocean temperatures. So on top, you can see that Walker circulation. So warm air is moving along close to the water, moving from east towards the west. It's coming up, it's dropping water, and then it's moving up along and circulating in that cell. The water close to the water surface is moving also from east to west, and that's primarily bringing warm water along that top level of the ocean. So what's going on there as it hits the western area of the Pacific is it's actually bringing a lot of extra water with it. So the ocean is actually higher in the western Pacific as a result of this motion. It's about 2 feet higher along the coast of Australia relative to where it would be along the coast of South America. The other thing I want you to notice in this image is something called the thermocline. And the thermocline is where you have the transition from warm water to cold water, here shown by light blue and dark blue. And thermoclines happen in lots of bodies of water. If you've ever gone swimming in a nice warm summer lake or in the ocean, you've probably had that experience where maybe your toe dips down, or maybe you go for a dive and you abruptly go from that warm water down to a much colder area. Water does tend to separate out by temperature because different temperatures of water have different densities. So we see the thermocline being lower, so lower down in the west, and higher up in the east, meaning that the cooler water is closer to the surface along the eastern Pacific than it is in the western Pacific. So the trade winds is really the engine that's driving this whole circulation system, both in the air and in the water. And it gives us what's called here our neutral conditions, our neutral Pacific conditions. And this is what we're going to judge our El Nino and La Nina conditions against. Now, neutral, does it actually exist in real life? Well, sometimes we're using it as the baseline to judge variations from. And when we're looking at what's closest to these conditions, our La Nina pattern is closest to these neutral conditions. And it's what we've been in globally for the past approximately 3 years. So this next slide, as it comes up, is going to show you what our oceans have looked like. And again, we can focus in on the Pacific between July 2020 and March of 2023. So a near 3-year series of time. In this condition, the trade winds are strong. They're moving that water exactly as we just explained. We have a lot of cool water along the eastern Pacific, so around the western side of the Americas, and a lot of warm water that sits close to Indonesia and Australia in the western Pacific. So this pattern tends to bring cooler weather to the northern part of the USA and drier conditions to the south, for example. It has a lot of other global impacts as well that we'll talk about in a second. So watch what's going to happen as I change slides to those sea surface temperatures as we move to an El Nino condition. So here, when you're looking at those colors, orange represents warmer than average or warmer than normal, and blue represents cooler than normal. So look at how this pattern is going to change moving into El Nino. Okay, so it should be coming up. There we go. So here is what our El Nino conditions look like. So you can see that our patterns of what those warm and cool anomalies look like have changed. And you may also have noticed that our circulation and where our precipitation is happening has also changed. So in an El Nino phase, those trade winds are weaker. We don't know why. It's enough to say that they're weaker. It's just the way it goes. We go back and forth. Sometimes they're strong, sometimes they're weak. And that warm pool of ocean water, instead of being blown to the western Pacific, just keeps hanging out in the central and eastern Pacific, keeping those sea surface temperatures much warmer than they are in a neutral or La Nina condition. In these events, we see increased precipitation in that eastern Pacific. So you can see how that big mass of air dropping precipitation has moved from the western Pacific area to the eastern Pacific area. And a lot of other changes have followed along with this as well. So again, to show us what happens then, not just with the air circulation, but also in the water, let's take a look at those two events. So in a normal or La Nina, we have that defined thermocline where we have a big pool of warm water over in the western Pacific and a big pool of cold water close to the surface in the eastern Pacific with those strong trade winds blowing things around. But when an El Nino year happens, we have those winds again being weak. They don't push that water away from the eastern Pacific. And instead we get this big separation of layers where this pool of warm water just sits on top of a large, large patch of the Pacific Ocean. And these weak winds are just not allowing those normal ocean currents to happen, leaving our layers to be much more what's called stratified, with a cap of warm water on top of a lot of the ocean. So our next slide coming up here is going to show you what we are looking at as of last week. So this is a map showing global sea surface temperature anomalies. So again, we're looking at an average, and then we're looking for which areas are above average or above normal and which areas are below average or below normal. So these are our sea surface temperature anomalies, where reds and oranges show you that it's warmer than normal and blues show you that it is colder than normal. When you look at this, you're probably noticing that the sea surface temperature anomalies look an awful lot like the slide that we saw of El Nino conditions. Is that enough to declare an El Nino? Well, the definition of when an El Nino is like written down in the history books as an El Nino is actually different depending where you are in the world. Each country and each meteorological organization has a different threshold for what they are going to call an El Nino event, which is then tailored to their specific interests. So, for example, Peru uses a different set of guidelines than the US uses, because Peru is going to look at what's going to impact Peru as opposed to what's going to impact the US. Makes sense, right? But overall, we're in pretty basic agreement about El Nino involves warmer than average sea surface temperatures in the eastern and central equatorial Pacific region. So if you look at the map there, you can see that there's a rectangular box just to the left side of South America. That is our El Nino region. So that is the region that we are looking at for sea surface temperature anomalies to tell us whether or not we are actually in an El Nino. And in the US, we use the NOAA, or the National Oceanic and Atmospheric Administration's guidelines, looking at a specific region of the equatorial Pacific when we have multiple months in a row where sea surface temperature anomalies are greater than about 1 degree Fahrenheit for several seasons in a row. So it's not a one-time event. They have to see a trend that's happening to be able to call it an El Nino. So right now, are we in an El Nino? Currently, we are on the cusp of being able to call it this or not. There are a lot of signs pointing towards the development of an El Nino, specifically the sea surface temperatures that we're seeing right now. Is it possible that it's going to sputter out and disappear? It is possible, but it's considered at this point to be very, very unlikely. Predictions currently are for an upcoming El Nino in the next months. So this slide here is showing you the official probability report as of April, looking at the likelihood for the next months being an El Nino shown in red, neutral conditions in gray, or La Nina in blue. And you can see that the further along we look, the stronger the likelihood is, and the more confident we are that we are looking at a shift to an El Nino. The jury is still out on how strong of an El Nino that's going to be, but NOAA did come out recently in the past week and say not only are they predicting an El Nino this year, they are actually predicting an El Nino for next year as well. So they are confident enough that as they look forward, that these conditions are going to persist, not just through 2023, but into 2024 as well. Now, excuse me, I did mention that this is a normal cycling event. And if we look at the cycles over time, we have been tracking these cycles scientifically for a number of decades. In this graph here, red represents El Nino events, where the higher the line is, the stronger an El Nino it is, so the warmer those ocean temperatures were. And a blue represents a La Nina episode, where the lower it goes, the stronger and lower than average the sea surface temperatures were. On average, each episode will last between 9 months to 3 years. In whether you're getting a La Nina or El Nino, we start to see these signs developing in the spring. So right around now, reaching peak intensity during the late fall or early winter. And then they tend to weaken again the following year if we're going to see a switch. Like I said, these can last more than a year. It's more rare for El Nino events to last longer than a year or two, and more common for La Nina to last for 2 years or more. The longest El Nino in the modern record was 18 months, and the longest La Nina was 33 months. We don't know why they're different. Again, all we can say is that they are different. And one thing I'll draw your attention to on this graph here is that there are events where you can see those straight lines on the graph running horizontally. That's our threshold for calling something an El Nino or La Nina. So there are years where neither one is happening, where we are closer to average than not. And then some years where it goes much further in another direction. We know from tracking a lot of different indicators that these cycles have been happening for a very long time, into the millions of years at least. Scientific record keeping goes back around 100 years. Other forms of record keeping, like historical records of the way winds blew during the big age of sailing, for example, go back more hundreds of years, but we can track back, like I said, millions of years. This leads me to tell you where the name El Nino comes from. Many of you probably know this. El Nino is Spanish for the little boy, and this was noticed by Spanish fishermen who were fishing off the coast of South America near Peru and Ecuador in the 1600s. It was a phenomenon that was noticed by them, but also in conversations with indigenous people of the area as well. It's named El Nino because it occurred around those winter months, around Christmas. And then when scientists kind of began to realize that there was a reverse phase back in the 1980s, they named it La Nina to give it the opposite side of things. So we don't have records of what some of the original indigenous names were, but we can certainly assume that this was a phenomenon that would have been noted by people living, especially in the Eastern Pacific and Western Pacific, for a very long time, as long as humans have been living there. So I think this has taken us really well through kind of the baseline of what's happening, like what's driving this phenomenon, what we're looking at for right now, and what our next year or two is going to look like in terms of probabilities. So let's look at what that means for climate systems, for humans, and also for other animals on the planet. So our next slide here is showing kind of our typical climate impacts that we would expect to see during a La Nina. And again, La Nina is a system that we have been within for the past 3 years or so. Again, our impacts are typically higher in the winter than in the summer, but it does affect summer conditions as well. Now, a word that I want to say about this before we start talking about these things. You may have personally had a different experience than this over the past 3 years. For example, you can see a great big blue blob over the Pacific Northwest and northwestern Canada. That represents colder than normal conditions. Perhaps you're going to say, Eleanor, I live there and it was beautiful the last 3 years. Well, that happens sometimes. We're talking here about large-scale climate trends, not weather trends. Weather is what happens every day. It's those short-term things that we are looking at. It's, did you get rain today? Yes or no? As opposed to, is it warmer or is it drier than average or wetter than average in a longer period of time? This is the difference between, for example, a number of years ago when we were facing a local drought. My particular farm got a normal amount of rain. We did not personally experience drought at all. 10 miles south, we had farmers who did not get precipitation for over 5 months. We were looking at a system where, you know, my weather was different than theirs. Our climate average for the area was that it was in a drought, even if I saw more rain and I saw a normal amount of rain. So just a reminder that here we're talking climate trends, longer term trends, averages, than what's just happening in a day to day. So looking again at La Nina, we can see that overall, on average, La Nina brings colder temperatures to northern North America. It brings warmer and drier conditions to southern North America, and it tends to bring cooler and drier conditions to the eastern South Pacific, so along Peru and Ecuador and through there. It brings warmer and wetter conditions to the western Pacific. So that is our La Nina climate trends. Our next slide is going to be what's going to happen in El Nino. Again, recognizing that these are climate trends, and whether or not you see these where you are is going to depend on your local weather, not these large-scale climate things. So you may or may not be able to see what those indicators are here. So the green circle or green oval through equatorial Pacific, that is representing a warm and wet area. Because remember, we have that pocket of warm water that's just sticking around in the equatorial Pacific. We are going to, on average, see warmer than average temperatures through northern North America, and wetter conditions through the southern western US states. The southern eastern US states are going to see, on average, cooler and wetter conditions. Looking at the western Pacific through those winter months, we are looking at dry conditions, especially through Australia and southern Indonesia, and continued warmer than average but drier than average conditions through India and the rest of our South Asian area as well. So we do see these big scale climate changes happening. We're focusing here on the Pacific, but we do see changes through Africa as well. You can see that in Africa, we have in the winter months, well, northern hemisphere winter months, a pocket of green that's representing a wet area, and then warm and dry in southern Africa. So it really is a global climate system that we're talking about, even though it's only being driven by changes in a single ocean. Just to zoom in a little bit on North America here, because I know that a lot of us who might be watching and paying attention to this are from North America. It will likely make a difference in your long-term weather forecasts when you're, if you're watching the news and they're going to say, well, is this summer going to be hotter than average, drier than average, or not? In an El Nino pattern, again, we tend to see those warmer and drier than average in the northern North America, and then wetter and cooler through the southern North America and the southern US states. It's sometimes a good thing for places like California. If you've been in a drought condition and you're looking for more rain, El Nino does tend to bring rain to those areas, but it brings those very dry, very warm conditions through Western Canada and the northern, like Pacific Northwest in the US. It also has a big impact on our storm developments, and it affects where you're more likely to have hurricanes forming, for example. So in an El Nino, there's actually a substantially decreased chance of a hurricane event in the Atlantic, and that chance then increases in the Pacific. So NOAA actually just brought out their hurricane forecast for the Atlantic, and they say it's going to be a no worse than average year, which we would expect again with potential El Nino conditions happening. In La Nina, we get different storms forming that tend to threaten the Atlantic areas and also have a major impact on some of the cyclones in the southern hemisphere. One of these happened just in the past few months. So between February 6th and March 15th, there was Cyclone Freddie, which moved from the northwest side of Australia all the way across Madagascar, hit the eastern coast of Africa, and then looped around a couple of times and went through actually 4 different re-strengthening events. It was a tremendously powerful and long-lived storm, and the only time we have seen a cyclone that had this degree of longevity and this degree of strength was in the 3rd year of a triple dip La Nina some decades ago. So the thinking around what may have driven Freddie to be so very powerful was that we were in that 3rd year of a La Nina system wrapping up this past February and March here. So changes in storms, changes in long-term climate forecasts. There's even a change in where the jet stream is located as it drives those circulation cells. Lots of changes that we are going to experience as humans in the next year and a half. And as you can imagine, this is also going to impact the animals that are out there as well. I know probably like a lot of you, if I'm experiencing a summer that's hotter than average, maybe with more wildfires than average, drier than average, I'm spending more time indoors in my air conditioning with an air filter running. If I'm a grizzly bear, I don't have the opportunity to remove myself from the environment like that. So it will have some major impacts on the ecology, especially of animals in that higher impact zone, which is the South Pacific and especially the eastern South Pacific area. So just take a second to remember here the difference between a La Nina year, which we have just left with that big change and where the cold water was versus where the warm water was, moving into an El Nino where our trade winds are disrupted and where we have that cap of warm water sitting on top of the Pacific Ocean and along the coast of South America. The biggest change this is going to have along those areas is a change in upwelling. Now, upwelling is a really, really important part of having a productive fishery. And the areas around Peru and Ecuador are an important area for human fisheries. It's very productive because of this deep water rising up along the coast. So remember that circulation pattern, that cold, deep water is moving from west to east. It comes up, it hits South America, and as it does that, it's forced to the surface. As that cold, deep water is forced along to the surface in that upwelling event, it is bringing with it a lot of nutrients that have fallen down over the years to the bottom of the ocean. And this is how oceans fertilize themselves. So they bring those nutrients from the depths up towards the warmer surface waters, which then encourages the growth of plant life. As your plant life grows, then your zooplankton can feed on them. And then your zooplankton, which are your tiny little animals like krill, then get eaten by fish, which are then eaten by bigger fish, which are then eaten by things like humans through a fishery. These coastal upwelling areas, especially along the eastern Pacific coast, are some of the most productive ecosystems in the world, and they support most of the world's important fisheries. And while these coastal upwelling regions are only about 1% of the ocean's surface, we get about 50% of our commercial fish catch from this 1% of the oceans. So they're a very, very productive and important area. And while I talked about that in the human context, this really does drive the entire food web, right? So our phytoplankton, which are our small floating plants, require nutrients to grow, just like plants in your garden. They like fertilizers sometimes. Without those nutrients, they don't have the ability to grow or to grow in as many numbers. Those little plants, those phytoplankton, they get eaten by our little animals, our zooplankton, which are then eaten by our smaller fish, sometimes called our forage fish, like herring, like mackerel, like anchovies, like sardines. And those smaller fish are then either eaten by big fishes, they may be eaten by marine mammals like sea lions or dolphins or whales, or they may be eaten by seabirds that have a forage strategy that relies on having those particular fish around to feed off of. Seabirds being birds that are reliant on fish for foods. Now, going to take, for example, the anchovy. So one of the world's major anchovy fisheries is off the coast of Peru. It's fed through this coastal upwelling system. Some years ago, back in the 1970s, Peru did have the largest anchovy fishery in the world by a huge margin. They caught nearly 10 million metric tons of anchovies in a single year in 1970. When an El Nino year impacted in 1972, there were quite literally no anchovies to be caught. So this is going to lead us into talking about some of our changes that we're going to see in an El Nino. And one of the kind of the big themes that I want to be talking about as we move through and look at these species is the resilience of those species to a major impact like an El Nino year. This species, the anchovy that had been fished in tremendous numbers, was being impacted well in advance of an El Nino event when their food source basically disappeared by us, by humans going out and fishing for them and taking tremendous numbers. This is one of the ways that we can see an impact on these species is when they're already being stressed, especially by human impacts or by other impacts as well, that then when another stressor comes along, they may not be able to be resilient enough to withstand that second stressor and to have population recovery. Now, today, the government has taken a lot of steps to ensure that this type of collapse doesn't happen again. So while in 1970, they took over 10 million metric tons, these days they take closer to 700,000. So a small fraction of what they would have taken. But this is therefore meaning that since the pressure from humans isn't as much, the anchovy population is more resilient to those periodic El Niños. And while they are impacted, for sure, and we'll talk about how strong that impact can be, they are therefore then more able to recover when that El Niño ends. So this next image here was taken in Chile in April of 2016, which was a very powerful El Niño year. It had a lot of stress along the coast. We saw major changes. And this kind of silvery stuff that you can see washing up on the beach here is about 8,000 tons of sardines that washed up along the coast as a result of that starvation, as well as heat stress. So we've talked so far about the lack of food source for our feeder fish, but do keep in mind that when that cap of warm water sits on top of the ocean, some of our species may be able to withstand an increase in ocean temperature, but some may not. And heat stress can impact the amount of fish death that we see as well. Now, if you are a seabird and anchovies are your food source, this may initially look like a great thing. Picture a gull and how happy a gull might be to come across a large kill-off like this and a large bounty of food that they can feed on. But the lack of food that happens as the fish and feeder population is recovering can then have quite huge impacts on the Pacific seabird populations during this El Niño time. And one of the areas that's particularly affected is the Galapagos Islands. We'll talk about this kind of as a case study and how it's affected. And then we'll extend this up the Pacific coast into some of the Pacific Northwest areas and into Canada. Because there's a lot of reasons that we discuss the Galapagos Islands when we're talking about El Niño. For one, it's right in the path of where the ocean currents usually are. In a normal year, the Galapagos Islands represent a very productive area where a lot of animals are able to feed in a very small area because there's so much upwelling happening, a lot of plants, therefore a lot of zooplankton, therefore a lot of small fish that can be fed on by lots of different kinds of animals. However, the Galapagos Islands are very far away from the mainland, and it does contain a high level of endemic species, animals and plants that aren't found anywhere else in the world. Now, one of the strategies you may have as a species that's being impacted by an El Niño year or any other bad year is to just decide not to be there anymore. You might say, this area isn't doing it for me, I'm going to migrate somewhere else. But because the species in the Galapagos are not found anywhere else, and many of them have actually lost the ability to migrate those distances, they are not able to do that kind of change into their life history. So it does put this area at higher risk. Like I said, it's usually a very productive area. It's fed by these main Pacific currents. It's one of the major upwelling areas as it churns up those nutrients, and it provides a lot of sustenance to many different levels along the food chain. And it is the basis for the incredible biodiversity that we find in the Galapagos. Now, again, as El Niño changes this, the upwelling diminishes, we get fewer phytoplankton growing, and we also then get less feeder fish for other animals to feed on. However, it's not the only other change that's happening here. remember that we didn't just see a change in what was happening with the water, we also saw a change in what was happening with the air circulation and where we saw a lot of precipitation happening. So in an average year or in a La Niña year, the Galapagos Islands are a fairly dry place. An El Nino event can bring a lot of rainfall to the Galapagos Islands. In fact, in 1982, 83, the average rainfall was closer to 250 millimeters. And then in the El Nino event, that was about 13 times higher, with over 3 meters, which is over 10 feet of rain in that El Nino period. So it's not just affecting what's happening in the oceans, it's also affecting what's happening on the land as well. But of course, oceans are our primary changers. So there's the upwelling, more phytoplankton happens in that nutrient-rich water. And this is like orders of magnitude more productive. So these are our Galapagos Islands, and these colors here around the islands are showing you what the ocean chlorophyll concentration is. That is a measurement of how many units of chlorophyll, so our photosynthetic chemical, able to take in solar radiation and churn out sugars, where those can be found and at what amounts they can be found. So in a La Nina year, one of those nice cold weather years with lots of upwelling, look at those dark green colors. That's a measurement of 30 milligrams per cubic meter. You don't really need to know exactly what that means, just know it's very productive. In an El Nino year, look at how blue those colors are. That's taking you, like, again, orders of magnitude. So instead of 30 milligrams per cubic meter, we're looking at maybe 0.1 milligrams per cubic meter. So really big scale of the differences here, again, then leading us to have a very big impact on these animals. So I mentioned that some animals may be able to migrate. This is one of my favorite birds. I think it's one of many people's favorite birds. If you are one of these bad boys, a blue-footed booby, you have options available to you. These are birds that are able to migrate away from high impact areas. They are found in waters along the Eastern Pacific, and they spend a lot of their time at sea searching for shoaling fish, like the anchovy, like the sardine. They do breed on the Galapagos, but in a bad year, they are able to change where they're breeding and change where they are feeding. So in an El Nino year, what they do is they go to the very, very limits of their range. They may go down to Peru. They may go down to northern Chile, in fact, where they are rare visitors, and only really during El Nino events. Now, this is one of those birds, and there are a number of them, where if you're a birder, an El Nino event is actually sometimes a welcome phenomenon because it really can push those birds well outside of their normal range as they search for new habitat and new sources of food. Now, obviously, this will still have an effect on these birds because they have to go so much further than they usually do and find alternate nesting sites. So nesting success is lower in an El Nino year than in a La Nina. Their clutch size may be smaller. They don't have as much hatching success or as much fledgling success. However, they do recover really well. There aren't any lagged effects. When La Nina comes back, they go back to normal business and go off, have babies, and everything is pretty well fine. The species as a whole is therefore not really a concern as far as El Nino events. The species that are not able to migrate, those species that are endemic to the Galapagos, are at higher risk during an El Nino event. This one is a Galapagos penguin. It is endemic to the archipelago, and they are found in very small numbers. At a high-end estimate, we estimate about 1,000 breeding pairs, but it may be, in fact, quite a bit lower than that. They feed on fish, like those sardines and mullets and anchovies, all of those fish that are highly impacted by an El Nino year. And they actually have a way of feeding off them that pushes them into the way of other birds as well. So they're actually helpful to other species. They are endangered because of their small size that has been reduced in the past number of decades, partially as a result of El Nino events as well. Because they do rely on those cold, nutrient-rich upwellings to survive, we do know that during an El Nino year, what will happen with these guys is that they will actually stop breeding entirely. They have a cutoff temperature beyond which they will not lay eggs. And that's around 25 degrees Celsius. Above that, they simply will not breed and will not clutch. Because this has been a population of birds that's been really impacted by other events in the past number of years, partially by humans, partially by natural events like volcanic activity. They are a population that has a lower amount of resilience to a natural event like El Nino like this. They recover slowly. Because they are not even able to clutch at all in an El Nino, we would expect to see a loss of population over the next couple of years, even if they're then able to recover in a following La Nina. They're not the only bird in the Galapagos to be impacted. This is the flightless cormorant, and you can see how it's flightless. Those feathers are not going, not taking this bird anywhere besides into the water. They also feed in the water. They feed on prey, including fish like sardines and mullets, but also octopus and squid. They feed in a very similar way to how our Galapagos penguins feed and are impacted in pretty well a very similar way. So there's another image there. Like the penguin, they are restricted to the Galapagos. In fact, they're restricted to only 2 islands in that archipelago. Incredibly restricted range, potentially very high impact species as far as El Nino events go. And they're on a similar level to the penguins when they have perhaps as high as 1,000 breeding pairs on the islands. So they are, like I said, particularly vulnerable because of past impacts. In fact, back in 1983, a full half of the population was lost due to starvation during a severe El Nino event. They're also then prone to things like nest flooding and volcanic eruptions that will go on to make them less resilient to those other impacts. Now, I will say that the population recently has stabilized due to conservation impacts and the reduction of invasive species around their nesting sites. So there are a lot of things that are happening to provide more opportunities for these species to be resilient during times of high stress. Now, we've talked here about the water birds. I will say, if you are a bird on land, if you are a seed-eating bird who lives in the Galapagos, an El Nino year is likely you going, yes, El Nino, because seed production jumps up incredibly during wetter years. So do know that I focused on some of the impacts that we were seeing on those seabirds, but we conversely see an opposite impact for a lot of our land animals because minus areas that are flash flooded, that increase in precipitation can then increase the amount of vegetation, can increase the amount of insects on the island, and can have a real beneficial impact on a lot of those land birds. Now, other sea animals, however, are impacted in the same way. So being a sea animal is just pretty tough in general. If you live in the Pacific during an El Nino, the Galapagos sea lion, however, does have more resilience because it's able to change its food source. It normally likes feeding on things like sardines, but it will feed deeper to feed on bigger fish if it can't get its upper level shoaling fish during El Nino. So they will likely decline in population, but not nearly as much as some of those other species will because they can switch their food source to something that will not be impacted. Again, other things as well, like marine iguanas, anything that's going to be feeding in the ocean will be considered vulnerable to an El Nino. Interestingly, the marine iguanas do have an adaptation. They are actually able to physically shrink during an El Nino year, not just in weight, but in body length. They actually resorb nutrients from their body to make themselves smaller and have less demand for food during a potential starvation event. So those ones that shrink more are actually more likely to survive an event like an El Nino. So cool thing, there are adaptations that come up. So just like anywhere else, anytime you're facing a stress like this, adaptations are evolved. Some animals will migrate and some are not able to do as well. Now, what happens as we move further north? Well, these impacts do come up again in sea populations as we move into the Pacific Northwest and along the Pacific shores of Canada as well. Overall, we are going to see impacts to animals that live in the ocean simply because there is less food energy in the system. If you're not growing plants, you're not feeding fish, then you can't feed your larger animals as well. So we do see, and we would expect that we would see a decrease in survivability or in population numbers of our land-dwelling animals through the northern Pacific area. And that does include our, California sea lions, who face a lot of other stresses as well, including from algal blooms that will also be more common during an El Nino event. As those sea surface temperatures are warmer, it does produce conditions where we are more likely to have toxic algal blooms, including of this the species here, which is called a pseudonychia, and it makes a toxin that is eaten by things like shellfish and is then eaten by fish, which is then eaten by marine mammals and sometimes eaten by humans as well. So this is one of those marine toxins that whenever you get a warning that now is not a time to go fishing, it's produced by plants like this. So I will say overall, you may be getting the sense that El Niños are bad across the board. But do remember that a lot of our land animals do get a benefit during this time as we see increased precipitation in these areas where we're not seeing that great impact in the waters. However, if you're thinking about what that means long term, you may be following the news about kind of what El Nino may look like in the future over the next decades. We're simply not sure yet what El Nino events are going to do as a result of overall warmer temperatures around the world and that climate change that we spend so much time talking and thinking about. Some forecasts have El Nino events becoming stronger, some have them becoming less strong. There's some that also look at how fast the cycling will happen and whether or not El Ninos will last longer or be shorter. And one of the predictions that's been looked at is that we will see faster cycling of El Ninos and La Nina. And there's a number of labs that have modeled what this means to the species found along the Pacific coast that are typically really highly impacted by El Ninos. So this is an animal called the Brandt's cormorant. It's endemic to North America. It is impacted quite a bit by El Nino years. Just like a lot of our other fishing birds, if there's less fish, our fishing birds don't do as well. There's a lot of long-term monitoring that happens of Brandt's cormorant. There's a big population that's found just off the coast of San Francisco, so easily accessed by scientists. And a recent modeling that's been done is looking at how these birds would fare in the event that El Niños start to cycle more frequently. And the predictions in advance of running these models were that we would likely see that these birds would be negatively impacted. And very interestingly, the model showed the complete opposite, that if we started to cycle El Niños more frequently, these birds would actually increase in numbers. And the prediction would also be that birds with a similar life history, like coastal dwelling birds that feed on shoaling fish, would also do better if El Niños became more frequent. And that sounds really weird to a lot of us. But the thoughts here is that if you're increasing the frequency of El Niños, you are actually therefore also increasing the frequency of La Nina, and it actually allows populations to recover more frequently and more quickly after an El Nino event. Those events will continue to be of negative impact, but because the opposite then happens more frequently as well, some animals will actually do better in a changed system like that than we would have initially expected. So, El Nino is still going to be bad for our fish-eating birds. However, we may actually see that that what's happening to these populations over time may not be what we expect. There's still an awful lot that we don't know. The climate's a really big system to look at what's going on. Now, I said that I would bring this back to polar bears by the end. So let's wrap up by talking about impacts on polar bears as a result of an El Nino. Now, polar bears are not found in the tropical Pacific. You may be aware of this. They're found in the Arctic, in the circumpolar Arctic. But El Nino is a global climate driver. And while we see effects in the Pacific, it can change what's happening everywhere in the world. Now, the biggest threat to polar bear populations is a sea ice extent decrease. Polar bears require sea ice to breed and to eat. And as we see climate systems warming overall, we see polar bears doing on average worse because they lose sea ice as we warm up the Earth. Now, does moving into an El Nino mean that it's going to get warmer? Not necessarily. However, if you take an average of the coldest years, they are almost always La Niña years, and the warmest years are almost always El Nino years. So it would not be crazy to say we would expect to see global climate being warmer in an El Nino year than it would be without the El Nino driver there. And this can have an impact on bear habitat. So right now, it is still very much sea ice season in Hudson Bay and in the high Arctic. And those bears, like I said, do require the sea ice to mate and to eat. And especially they require sea ice in the springtime. And unfortunately, we've seen that as global temperatures increase, we are losing a lot of sea ice, particularly in the fall and the early winter. So you can see those are sea ice anomalies where red shows you a lower than average amount of sea ice. However, this trend is still there, but not quite the same for our spring sea ice. So you can see our June sea ice anomalies are not nearly as strongly decreasing as they are in the earlier part of the winter. June, by the way, is still very much the tail end of winter if you are in the Arctic. There's still a lot of ice. What this means for the bears is that it is very likely that we would be looking at a year, should it end up being an El Nino, where we see warmer than normal temperatures and a general increase in global temperature. That would lead us to see very likely a decrease in the amount of ice and a decrease in the number of days that polar bears are on ice in this coming year, as well as perhaps next year as well. That's perhaps good for some of us who like looking at bears, because it's likely that they're going to have to spend more time on land, especially in the fall. Now, let me repeat again, we're talking climate. This may not be a realistic interpretation of what the weather is like in Churchill in November, for example. We're just talking long-term trends. But this, like I said, this doesn't always extend into our spring months. Now, bears show their most resilience if we can protect their springtime ice, because that is the time when they are using the ice to mate, as well as to eat a lot of sea ice, seal pups. So this kind of brings us back again to our resilience and looking at ways as humans that we can have a lower impact and better support these species so that when these natural variations come along, and again, we are looking at this being a very normal event. We are always either in an El Nino or a La Nina or a neutral system, and we always cycle between these. We have to make sure that the populations of animals that we care about are able to be resilient to these changes that are normally happening within the global climate system. So with that, I know I've taken it right up until the hour here. Sorry about that, Sunny, but I have a few minutes for questions if you have a few minutes for questions.
I wouldn't have wanted you to keep any of that out. It was fascinating and it's so complex. And we really appreciate you kind of breaking it down for us. Fortunately, there's not a lot of questions at the moment, a lot of compliments. There is one request for you to explain the seasonal designations on the prediction graph.
Oh, the
That was
seasonal
way at the beginning.
designations. Let's go back. I will scroll way back here. Nope, there. I hope this is the one that people were talking about here. The seasonal designations on the predictions, so the probabilities. So this is where I was saying that El Nino is the red. So we are right now in the bottom of the graph here is just a month. So the AMJ is April, May, June. So we are confident for that pocket of 3 months to, what are we here? We're about a 30% confidence in the April, May, June pocket that we'd be looking at El Nino conditions. But as we move into like JAS, which is then July, August, September, NOAA is maybe closer to an 80% confidence level that we are looking at El Nino conditions. And those predictions, especially as we move into the fall, like November, December, January, are closer to a 90% confidence level. So they are very, very confident that we are looking towards El Nino conditions in the later half, especially of 2023.
Excellent. So a little clarification. Did you mean that El Nino, I'm sorry, in an El Nino year, Iceland and Greenland will be warmer?
In an let me just pull up a map here because maps are always helpful. So an El Nino year, will Iceland and Greenland be warmer? Iceland and Greenland they will likely be warmer in general. So again, caveat here that we're talking climate predictions, not weather predictions. If memory serves, we'd be looking at a warmer temperatures on average because we would be looking at a global climate that is warmer on average. And the poles, like areas towards the North Pole or the South Pole, tend to show warmer temperatures than we see towards the equator. So if we're warming up the Pacific, that actually warms up the poles very effectively as well. We would, however, expect to see less precipitation than average. So I've got El Nino up on there right now. I'll just switch it back to La Nina. So in La Nina, we would see on average more precipitation in the Western Atlantic area than we would during in El Nino. So if you're thinking about, well, will I be able to land in Greenland? It might mean, right? Weather is always different than climate, but it may mean that you have fewer fog days or fewer rain days or cloudy days in that area as well. So it may have an impact on your trip, for example, if you're going up there this summer in that way, even if it's not that warm because it's still Greenland.
Got it. Thank you for that clarification. One more question. We have a viewer who's planning a trip to the Galapagos in December. Do you have some predictions for the El Nino at that time?
Do I have predictions? Well, I'm not a climate scientist, but I'm glad that we do have predictions. Not from me, so there's our probabilities coming up right away. It's going to just cycle there for a second. So December, we are looking at a very, very high probability for El Nino conditions. That would mean that temperatures would likely be warmer, precipitation would likely be higher, and that's water temperatures would likely be warmer as well. It can, like in terms of what the viewing will be, the viewing may actually be great. You might have a lot of bird activity. You may have, if you go snorkeling, for example, you might have lovely warm water and the ability to see a lot of things being active because they're out there looking for more food. And then you'll have that knowledge in the back of your head that if we are looking at an El Nino, that some of the conditions that those sea animals are facing are very challenging for them. Whereas the conditions that we see for a lot, not every land animal, but a lot of land animals are less challenging. So again, it is that normal cycle. It goes back and forth, and it has as far back as we can look in the records, as long as we've had a Pacific Ocean of this size. So these may be some of the things that you see in the Galapagos this winter.
Wow, so much to put together in my mind. It's a very complex thing and affects so many things on this planet. So again, thank you for tackling that topic. I'll hand it back to you for closing comments.
Yes, thank you very much. I hope that, I learn things every time I sit down and do a webinar. So I hope this was helpful and educational, and it's made us think about maybe what we're going to be looking at this summer and in the coming months. It's always best to kind of have an understanding of what's driving the climate around us. So I hope that it's been useful for you, and I hope you go out there and pay attention to these predictions and just have a wonderful day in general. It's a big topic. There's a lot to unpack. And again, your local weather may always be different than our climate predictions, but overall, these are averages that we are looking at. So here's hoping that we all get some good rain and good weather this summer so we can get outside and enjoy stuff.
Sounds good. I want to thank everyone who tuned in. Please join us again tomorrow for our next Daily Dose of Nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, we'll conclude the webinar. Have a wonderful day, everyone.